To derive energy, a nuclear power plant uses unstable isotopes of an element which can be easily split. A common isotope used in nuclear power plants is uranium-235, which undergoes fission. Uranium-235 is an isotope of the uranium element. Isotopes are versions of an element with differing numbers of neutrons, some of which are more stable than others. If an isotope is unstable, it will find a way to become stable by undergoing a process called nuclear decay. The decay process often occurs slowly, but this rate can be increased, and in uranium-235's case, by bombarding the material with neutrons. As a result, a nuclear reaction occurs where two smaller elements are produced, along with 3 neutrons and energy in the form of heat. These 3 neutrons in turn cause a chain reaction to occur. The released heat is then used to boil water, which powers turbines to produce electricity. The Fukushima Daiichi nuclear disaster occurred in Japan on March 11, 2011. Earlier, an earthquake had hit off the coast of Japan, with a massive tsunami occurring directly after. When the nuclear power plant detected movement in the ground from the earthquake, it immediately shut down, stopping the fission reaction that was occurring inside. However, the leftover heat, called residual heat, was still present even after the fission reaction was halted. The plant had a cooling system, but that was disrupted by the tsunami, and the backup diesel generators were also interfered with when the tsunami hit. Now, the meltdown was in full action.
Cesium-137 is the radioactive material that seeps into the soil daily and contaminates groundwater below, and from that contaminated water, it seeps into the Pacific Ocean. Cesium usually has an atomic weight of 132.9054, which comes from 55 protons and 78 neutrons. Meanwhile, in cesium-137, there are 5 more neutrons, making it an isotope of cesium. About 300 tons of contaminated water is released into the ocean every day, years after the incident. Fukushima's radiation is already more than 5 to 10 times more than the radiation released from an atomic bomb. While there have not been major side effects on the radiation on humans, it has caused fish-near candidates to bleed from their mouth, eyes, and gills. If we don't actively try to fix this major issue for the future of the Earth, this radiation will only get worse and begin to be seen more and more through symptoms in humans and not only fish.
So in actual cases of nuclear meltdowns, such as Fukushima in Japan, Chernobyl in Ukraine, and 3 Mile Island, USA, they show how they're extremely harmful to the environment, especially when it comes down to radioactive material. But through all of this, it does not mean we should stop trying to harness the power of nuclear energy. Today, scientists and engineers are constantly trying to prove the effectiveness, efficiency, and especially safety of today's nuclear reactors. Some significant problems that arise from older reactors are the insertion of control rods requires energy. In the case of no energy, control rods will not be able to use and lead to a meltdown. The circulation of cold water requires energy as well. Without the ability to circulate water, meltdowns could occur much easier. Compared to newer generations, some improvements made is the ability of controls being electrically independent, along with some others.